Welcome back to the Basic Radio User Training Program sponsored by the Heart of Texas Council of Governments Homeland Security Division. In the last unit, we discussed the various governance structures and guidance documents that relate to emergency communications at the local, state, and federal levels. In this unit, we will take a detailed look at radio operation and the features available from the equipment that we utilize on a daily basis. One of the greatest challenges facing emergency responders and emergency managers today is the overwhelming capabilities provided by the many different technologies that we are expected to use. All too often, these technologies are provided to us with little or no instruction. When we complete the police or fire academy and become employed, we are issued a radio and expected to understand how it functions, although most academy curricula does not provide a detailed explanation as to how this equipment works. For our volunteer responders, the issue is compounded. Many volunteers find the need to purchase their own equipment in an effort to achieve operability with fellow members of the department. The lack of formal education on radio operation and use forces us to rely quite a bit on what we have experienced elsewhere and what we have seen on TV. Today, we hope to address that problem by providing introductory exposure on the often undiscussed capabilities of the equipment that we carry. Radio system resources that we use regularly can be categorized as either subscriber units or infrastructure. Subscriber equipment, often referred to as end user equipment, encompasses any equipment that allows the end user, such as the deputy, officer, firefighter, or EMT, to communicate with other end users or dispatch. Infrastructure can be thought of as equipment or assets that one might find at the tower site. Typically, the subscriber or end user is not required to operate infrastructure. The operation and management of infrastructure is commonly conducted by system owners, system managers, or system administrators. While these resources require no direct operation by the subscriber, they are vital for both operability and interoperability. Think about these concepts in terms of your vehicle. When you need to travel from point A to point B, you use your car, truck, or SUV to get there. In doing so, you use the driver's seat, gas and brake pedals, and hopefully the turn signals. Essentially, your vehicle is your subscriber unit that enables you to efficiently travel across large distances. Now, your vehicle requires the use of multiple technologies to function effectively. The electrical system ensures that the car starts and your blinkers work. The engine ensures that the vehicle runs and has the power to propel you forward or backward. The braking system ensures that your vehicle stops when you need it to. The road underneath your vehicle provides a common path between locations. These various systems correlate to the infrastructure that your radio system is built upon. Chances are that you do not have to work on the road or rewire the engine every time you need to use your car. You get into your vehicle and expect that these systems function appropriately each and every time you need them to. Subscriber unit refers to the portable or handheld radios, mobile or in-vehicle radios, and base stations or consoles in use by responders and dispatchers. While the most common types of two-way communication equipment are displayed, there are other types of subscriber units that exist. For instance, many volunteer fire departments and special response teams utilize pagers, which allow for one-way communications. In these cases, dispatch can activate and talk across the pager, but the responder cannot talk back to dispatch through the pager. The capabilities of the subscriber unit depend on the type of equipment and the manufacturer of that equipment. Today, more radio features are customizable than not. For instance, the Kenwood TK5220 portable VHF radio that is commonly used by agencies across the region allow for the custom configuration of all but two buttons or knobs. The only buttons or knobs whose use cannot be modified in this particular radio are the volume knob, which must control the subscriber unit's speaker volume, and the push to talk button, which must activate the unit's microphone and transition their microphone into a temporary transmit mode. Portable or handheld radios typically operate at a power of 3 to 5 watts. Mobile radios, or those radios mounted in vehicles, commonly operate between 20 and 100 watts. The higher the wattage, the farther the radio can broadcast or send messages. Under these circumstances, mobile radios have a far greater reach than their handheld counterpart. Radio power is only one of many characteristics of the equipment that we use. Most radios in use within public safety today typically have the ability to scan multiple channels, choose between channels or groups of channels, send audible tones, and much more. The images shown here demonstrate the variety of customizations that can be made to the button configuration of modern subscriber units. For equipment with a digital display, additional features may also be programmed into a user-friendly menu, making our radios nearly as powerful as our cell phones. The ability to customize almost every aspect of the radio's programming ensures that the dynamic communication needs identified by today's responders can be quickly and effectively addressed. This also means that agency leadership and radio system owners must plan in advance for how radios will be programmed and used. Furthermore, this extreme flexibility necessitates need for development of local SOPs that document how radio equipment will be programmed and what features will be utilized by department or agency personnel. Thinking ahead today prevents operability and interoperability problems tomorrow. Subscriber equipment allows the user to interact with the infrastructure used by the agency or jurisdiction. The equipment that comprises the infrastructure enables communication pathways to exist. Channels and talk groups act as these pathways. Both channels and talk groups are founded from the frequencies licensed by the Federal Communications Commission. Channels consist of either a single frequency or a pair of frequencies that enable users to communicate on a conventional system. Talk groups consist of a set of frequencies whose actual use are coordinated by a computerized controller within a trunk system. We will talk more about conventional and trunk systems later in the course. Frequencies act like the road beneath our vehicle. They allow communications to flow efficiently from one physical location to another. In order for channels to work, there may be additional information that the radio needs. CTCSS, PL tone, and other terminology tends to be manufacturer specific, but relates to the use of subaudible or inaudible tones, tones that we don't hear, that serve as a sort of audio filter. They are used to prevent interference by not allowing transmissions that do not encompass the appropriate tone to pass through the radio or repeater. As the capabilities of subscriber equipment have increased, so has the capacity of radios to hold channels. 15 years ago, it was relatively common to find radios capable of holding only 4 channels. Today, it is not uncommon to find radios capable of holding more than 500 channels. Obviously, placing all 500 channels together in a single light would create a nightmare for the user when they need to locate a specific channel or talk group. To remediate the issue, manufacturers have included the ability to separate channels or talk groups into more logical lists. These lists are called zones or groups, depending on the language chosen by the manufacturer. Each zone or group may consist of one or more channels. The availability of this feature, as well as the necessity to divide the many channels utilized by modern response agencies into local groups, means that agency or department leadership must plan ahead to determine how channels, talk groups, and zones are configured. This also identifies the need for establishing a standardized programming list to ensure that all radios are configured appropriately within the department, agency, or jurisdiction. Simplex systems are the simplest of radio system constructs that exist. A simplex system relies on channels that are comprised of a single frequency. In these systems, there is no infrastructure equipment to expand the coverage of the system, and therefore the ability to communicate is limited to 2 primary factors. Coverage is limited to the transmit and receive ranges based on the capabilities of the individual subscriber units in use, and a frequency can only allow communications to flow in one direction at a time. In the graphic illustration, the officer can begin transmitting and both vehicles will hear him or her so long as the range of the officer's radio allows the transmission to reach the vehicles. Additionally, while the officer is talking, neither of the vehicles can transmit until the officer stops transmitting from his or her radio. The most common application of a simplex system is the use of interoperability channels to support day-to-day, event, and instant operations. The interoperability channels are typically configured to be used in a simplex environment. These types of channels were formerly known as car-to-car or truck-to-truck channels. Repeated radio systems are those systems most commonly utilized throughout the HOTCOG region. In repeated radio systems, access to each channel is provided through the installation of a repeater. Repeaters are programmed opposite of the subscriber units they service. We'll talk about why this is the case momentarily. The inclusion of repeaters increases the coverage of the system due to increased effective power of the repeater as it retransmits messages and the height of the antenna on the tower site. In order for communications to pass through the system, subscriber units must be in range of the repeater, meaning that their transmission must be able to reach the repeater. Additionally, the subscriber units must be close enough to hear the information that is broadcasted by the repeater. Typically, the receive range of subscriber units on a repeater system is significantly greater than the transmit range. This image demonstrates why the repeater is programmed inversely from the subscriber units and how the repeater functions. The designators F1 and F2 represent the specific frequencies licensed to an agency or jurisdiction by the FCC. You'll notice that the repeater's transmit frequency also serves as the subscriber unit's receive frequency and vice versa. When the user keys up the radio or presses the push to talk button, the subscriber unit begins to broadcast the message to the repeater on the first frequency, or F1. The repeater listens for any messages or traffic on F1, then repeats or retransmits the traffic on F2. Subscriber units that are in listening range of the repeater then receive the message. While this multi-step process may seem like it would take a while, transmissions across the system are nearly instantaneous. Voted systems are an extension of repeated systems. Within a voted system, the repeater continues to serve the same function and is programmed in the same way. In remote areas where subscriber units experience difficulty in reaching the repeater, voter sites are installed. The voter site consists of a radio receiver, much like a subscriber unit that only listens. The radio receiver passes traffic back to the repeater through a microwave backhaul or internet-based connection. At the primary site where the repeater is located, a voter comparator evaluates the traffic from each remote receiver, as well as the traffic received by the repeater, and determines which has the best signal quality. The comparator then passes the best audio to the repeater to be retransmitted back to the subscriber units. Again, while this multi-step process might seem time-consuming, communications are near instantaneous. In actuality, the voter comparators process signal quality in real time, ensuring only the best quality signal at any given time is passed along. When considering radio systems, you must understand that the more equipment that exists within a system, the more potential exists for things to go wrong. Voter systems can experience significant issues when a single voter receiver is damaged or not working correctly. The comparator evaluates signal quality based on the amount of noise present, and a voter receiver that is not functioning will pass no audio. In the absence of audio, the comparator calculates that there is no noise and begins to attempt to transmit the non-existent audio. When this happens, the system will pass static to all end users. One of the greatest challenges to utilizing repeated systems is that the transmit range of subscriber units is extremely limited in comparison to the range in which the same equipment can receive. This image demonstrates that very limitation. In this scenario, the portable radio can receive audio from the repeater because the repeater is capable of broadcasting for a greater distance due to its power and antenna height. However, if the user is in a remote area, their equipment does not have the transmit range to reach the repeater. This results in the officer, medic, or firefighter being unable to communicate effectively and reliably with dispatch or other responders. The integration of a voted system extends the repeater's ability to hear the traffic coming from subscriber units in remote areas. Basically, the voter receiver acts as an ear for the repeater. Subscriber units still receive audio from the repeater, as the remote receivers do not transmit outward. However, when the remote receivers hear transmitted audio, they pass it along to the voter comparator, which then passes only the best audio to the repeater for broadcast. Wow, that's a lot of information. So far, we've covered the concepts related to simplex and repeated system design. However, there are times when a middle-of-the-road solution may be needed. In these circumstances, a repeater talk-around or direct channel might be utilized. A direct channel allows the subscriber to monitor broadcasts from the repeater and talk to others who are monitoring the same receive frequency without tying up the repeater. This approach is typically used when a repeater fails and responders need to be notified to change channels. As with simplex channels, the subscriber units must be within range of one another for communications to reach both parties. Each of these types of systems, as well as voted systems, are considered conventional systems. Trunk systems consist of two or more repeaters that are connected to a common antenna through a computer system. This type of system is designed to allow more users to access the system at a time and reduces the waiting time for channels to be clear. The computer system evaluates system demand based on the number of talk groups attempting to broadcast a message. The computerized controller assigns available frequencies from the system's frequency pool to address these demands. Subscriber units are grouped into dedicated talk groups, much like conventional systems group subscriber units into dedicated channels. When a radio keys up, the computer notifies all other radios to switch to a specific repeater and begins passing traffic across the system. This computerized switching does not require end users to take action. Users still only need to select the appropriate talk group in which they desire to communicate, just as conventional system users need only select the appropriate channel. In the event that the system is overwhelmed by demand and there are no more system resources available to address the demand, the system will pass an audible tone across to the user attempting to transmit a message. This tone sounds like a bonk and alerts the user that the system is busy and the user should try again to broadcast. Trunk systems are composed of four components. The system ID relates to a specific identification number established by the system administrator that pertains only to that specific radio system. The radio ID is a unique identifier issued to each subscriber unit so that the unit's access to features of the system can be allowed. We've already defined talk groups. Control channel frequencies are the frequencies utilized by the system to coordinate the use of repeaters and talk groups while minimizing system load. Should any of these four components fail, the trunk system fails. Radio systems are considered digital or analog based on how audio signals are processed by the infrastructure and subscriber units. This is true for both conventional and trunk systems. This means that it is possible to have a digital conventional system, an analog conventional system, a digital trunked system, or an analog trunked system. Are you confused yet? Don't worry, we'll straighten this out. We have discussed the differences between conventional and trunk systems. The concepts, benefits, and considerations of each system type remain the same regardless of whether the audio is digital or analog. Analog signals are processed based on the waveform shown in the image. Imagine driving your vehicle down the interstate. You're listening to your favorite radio station as you travel. The kids are singing along in the back seat. As you travel further from home, the radio station begins to drop out. You hear a bit more static and it becomes harder to hear the music. As you travel even further, you cannot hear any music at all and now only hear static. Analog public safety radio systems operate in the same manner. Digital systems, on the other hand, operate much like a flashlight. It's either on or it's off. Digital signals either meet the standards for audio quality within the system and are passed through clearly, or they are dropped completely from the system. Project 25, more commonly known as P25, is a set of standardized capabilities intended to provide reliable and efficient digital communications. Prior to the establishment of P25, land mobile radio equipment manufacturers created their own sets of standards. Motorola had Astro, Kenwood had NextEdge. Today, the P25 suite of standards is shared across many different manufacturers. Please be aware that not all manufacturers produce equipment that meets the P25 standard. However, when using federal or state grant funding to acquire equipment, P25 equipment has to be purchased. Most public safety radio systems operating in the Hot Cog region today are analog systems. However, there are a number of systems that have migrated to P25 operation. This migration provides clearer communications and appears to have slightly increased the range of the radio systems for the areas that have been tested. While the feedback from users of these digital systems has been positive, migration of all communication systems within the region is impeded by the cost of infrastructure and subscriber unit replacements that would be required. Throughout Unit 2, we compared the differences between subscriber units and infrastructure. We also discussed system design considerations, the use of simplex channels, direct channels, repeated systems, and voter systems. We differentiated between conventional and trunk systems and discussed the differences between analog and digital systems. After watching this video, please complete the activities below in order to unlock the next unit of instruction. We'll see you in Unit 3, where we will talk about the applications and practical uses of land mobile radio systems. Until then, stay safe, be aware, and keep up the great work that you do in your community.